Next session will take you to outer space, the stars, the galaxy, the planets. Whatever you see on the big screen will happen here right away. And I'd like to invite the session moderator, Mr. Raj Changappa, Group Editorial Director, Publishing India Today Group, the conversation, the Space Quest, and the speaker is S Somnath, Chairman, Indian Space Research Organization.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
लिफ्ट ऑफ नॉर्मल
प्रज्वलन और सफलतापूर्ण उत्थापन GSLV F.
The Shah ground station is currently tracking.
वर्तमान में प्रथम चरण प्रज्वलित है.
Good afternoon, ladies and gentlemen. That spacecraft that you saw was GSLV F-12. And let's give the chairman of Isro, Mr. S Somnath, a very warm round of applause for that. Congratulations, Dr. Somnath, for that tremendous success. You've got that satellite up. But I want to look back a bit in 2021. A GSLV went up and there was a failure at that particular time. What was the problem at that time and how did you sort it out?
Once a failure occurred, we go through a very serious action of failure analysis. We collect all the data from the rocket, which is telemetered to the ground, and go through the simulations in the ground to see what could be the reason. See, Raj, you know that you can't retrieve the failed rocket, unlike the failed instruments that you may have in ground. Right. You can always probe and find out what exactly went wrong. But here we go through a process of called simulation and try to see what exactly could have gone wrong, and various
so what went wrong?
Hypotheses are put up. Okay, I'll come to that. Essentially, the issue in that mission was leakage of hydrogen. The hydrogen is there in the tank of the cryogenic stage, and at liftoff, there is a certain valve which is supposed to close. It did close, but it closed just a bit lesser than what it's supposed to be, say a few microns. It left a gap there. And through the gap, the gas was leaking slowly, very, very slowly. But by the time it was just about to get ignited, the pressure in the tank was slightly below the threshold at which the pump will have to see a pressure. Unless that pressure is not there, the pump gets into a mode called cavitation. The cavitation is a condition in which the liquid will start boiling at the end of the pump. And once it starts boiling, it cannot pump it. Its speed increases, it doesn't deliver the liquid to the engine, and the engine stops developing. And our onboard computer found out that this engine is not developing the required thrust. So as to save the mission, it is told to cut off at that point and separate the satellite. So it did that, but unfortunately the satellite is not having the velocity, it will fall into the Earth.
But congratulations for correcting that error that was there, fighting back, and that I think is the hallmark of Isro. It never lets itself down. And I think that's a big lesson that you learned in terms of this thing. And of course, space is unforgiving. Even out of 99.9, you could get it right, but even that 0.1 could destroy whatever mission you had.
That's the challenge, and that's the beauty. So we enjoy it only because it is very risky business.
And while you were there, this satellite, I gather the NavIC or whatever the designation you've given it, is up in orbit and working at the moment, or is approaching its geostationary
We went through a process called raising the perigee to an apogee size. It was injected to an elliptical orbit of 170 kilometer by 40,000 kilometer. It has to emit 36,000 kilometers circular, and it also has to go to a precise location in its orbit, and also its inclination to the equator.
So the news is everything is normal on that.
Now we did all that processes. The final orbital correction is completed. It's already in the equatorial orbit, but it has to drift to reach the right place. That will happen in the next few weeks.
And you're confident that will happen? Yeah. Coming to the satellite itself, now India has built a GPS system. This is one of the, or maybe the fifth satellite that will go and sit up there and transmit. Why did we need a GPS system like that? We could have used the other GPS systems that America and others have. Why
so we have been using GPS of the US. Let us understand, Raj, that the GPS is a US installation. It's a US creation. It was originally created for the strategic need of the
GPS, by the way, is all the Google stuff that you use in your car. And suddenly India has one, so just to explain, it's not a very technical thing.
It's a global constellation. It's there everywhere. You can see it. You can get the data in anything. But it was originally a military system. And realizing the commercial potential and the public utility, it was transferred to the civilian domain. But still, they have the civilian segment and the military segment, which the military segment, none of you are able to access. Only their military installations and equipments can access that code, which is secured. Now, talk about the GPS. It gives you certain accuracy and availability. There are 2 points. One is called accuracy and second is availability. And availability in the control of the people who are actually providing it. So that means if they don't want to give GPS service at this location, it is possible for them to switch off or make it inferior, that your accuracies will drop to hundreds of meters. Now think of a situation that if you put GPS into any of our systems where we are doing vehicle tracking, railway monitoring, Aadhaar installations, or ship tracking, and also military equipments and devices, and the GPS is inferior at that point, in a situation which is of conflict situation, and somebody decided that it has to be inferior, then we are taken for granted. It cannot be. And we realize that it cannot be, and we need to have our own systems in case that you have a need to protect our installations and systems. And that's why we thought of a concept called IRNSS, which was later named as NavIC. And this is not a global system like GPS. GPS is created as a global system because US needs it. They were a global military power. We are not. So we looked at it how a GPS system or equivalent can be made for India and its neighborhood, which will serve the purpose which I mentioned, which is basically a strategic purpose. So we defined a different architecture, which is not of GPS nature. Which is a GPS goes in a MEO orbit where we are stationary. The satellites are stationary there and looking at only India. This gives us a distinct advantage. It is much more accurate. It gives you less than 3 meter accuracy when all the 7 satellites are there, which is not GPS doesn't give.
So in effect, these set of satellites makes India self-sufficient.
Sure, yeah, it's not only self-sufficient, that you are the decider of your destiny. And what secure. You want to do with your satellites, you can decide.
Secure, strategic ones. Yeah. But let's come to a more, I think this is the thing that's very popular. Chandrayaan is about to go up, and this is Chandrayaan-3. Yeah. Tell us about this mission, our mission to the moon, and what will it do? What's it different from Chandrayaan-2? And when is it going up?
Yeah, essentially, Chandrayaan-3 is similar to Chandrayaan-2 in terms of its architecture, the scientific objective, the mission, everything is same. But what we did is that we had a failure in landing safely at the required velocity in the lander, but the orbiter is still there. It is working beautifully, giving the scientific instruments, are doing the measurements, and we are getting enough of data. But the final target of landing softly on the moon could not be achieved. So we took pains to understand why it went wrong, and we are very clear in the similar lines as I mentioned about the GSLV. We did a failure analysis. We found out through simulations what could have gone wrong. Again, no message came from there, I am wrong here or bad here, but we could synthesize it and understand over a period of time.
And can you tell us what was the problem? Simply, we don't want too much of detail, we're not a technical thing.
Yeah, of course, I will tell you, it's an error. There was an error sitting in the software.
Sorry?
An error sitting in the software.
Okay.
But the error sitting in software will always will not be triggered because there are conditions that will drive you to that error. Those who are in software business will know that always software even if an error is there in the software, it may not be triggering, causing a mission failure. But there are some of the situations or some of the conditions prior to that drove the system to that software error. And once the software error occurred, the satellite lost its control. It couldn't realize that it is at this height, and this crash landed.
It was not anything to do with the mechanical processes of the lander that was there or any of that?
No, nothing to do with the mechanical element of it. But of course, there are some mechanical reasons behind the initial conditions which caused the later problem. So of course, that requires a lot of complex explanation, of course.
Sure. No, I mean, just of it, you have been able to overcome it. You're confident. Now, this is going up when? In July?
No, we are trying to put the launch in a window which starts on 12th of June. It will be a very short window because we need to launch it only at the right time when the moon, sun, and the earth locations are appropriate for us to minimize energy required. So the date will be announced soon.
We're also quite excited about the fact that finally we are going to put India, our own mission in space, a manned mission in space. Yeah. Now, when is that going to happen? Everyone's asking, it's Gaganyaan. Where have we reached? What is the progress? And when can we see finally our indigenous effort to put
we want to make sure when that launch
women
happens.
In space, sorry.
Yeah,
I should be gender sensitive. Women in space as well.
Okay.
Yes.
So you always say human in space rather.
Human in space, okay.
Yeah. So when it happens, it must be the one in which we are very absolutely confident about its success. We have to reach that state. Of course, we know we have rockets which are flying safely. And all of you know, Raj, there can be anything that can go wrong in a rocket. And if it really goes wrong, we need to save the crew. So crew escape system must be perfected. So the first goal is to perfect the crew escape system, and we are working on it. And it will take a few missions. Right now, we have to have at least 4 missions to demonstrate the crew escape system will work when it demanded at critical junctures in the mission. Second point is that we need to do unmanned missions, robotic missions initially to prove the end-to-end capability of the design, development, communication, networking, and bringing it back, all are working properly. And that has to be repeated at least 2 times, maybe more. We'll have to see. And all of this is success-based idea. No, if anything goes wrong here, it requires correction and further launches. So I'm not putting the date for the launch of the final human mission. It's not important at this moment. Our focus is to do what is needed to reach that point. And when it reaches the point, all of you will tell, why don't you do the human mission now? More than Isro, the nation will tell us, you are ready for it, you do it.
Right.
So it is my responsibility to showcase to the nation, the scientists, that we are reaching that state. Right. Otherwise, all of you will criticize me. If I take a plunge into it and cause a hardship to anybody who actually flies on the vehicle, you won't pardon me.
Right.
And the nation won't pardon you. And it's very important for us to do very carefully. Unless you do that carefully, this will not be sustained in India.
Human lives involved.
You think of a situation that there is the first mission, there is a failure and human life is lost. Do you think that we will repeat it? It will be extremely difficult for all of us to reach a situation that, yes, we will try once again. Not possible. So we have to have absolute clarity on either we go to orbit, or if you face a mission failure or any other problem, we save the crew. This has to be done. So that is the essence of the whole work.
So essentially what you're doing now is there is a crew safety system, which means if there is a failure after takeoff, the crew can be ejected out, and that's what you're going to test right now.
Precisely,
that's one.
yes. Yeah.
That's the one. The second thing that you're saying next year is you will have a crew spacecraft, but there will be nobody inside it.
Correct.
It'll orbit so that you'll know whether it is safe. Have you also built the environment, because you need the oxygen and you have to make it human compatible? Has that also technology been achieved?
Yeah, it's a difficult technology. Only very few nations have really. It's available only in 3 nations today. And we approach them for help in developing it. But the help is not that forthcoming. I think you must understand that it is not easy to get those helps. Some of them offered it, but they were telling they will take few years to develop it and at exorbitant cost. And after analyzing the merit of these offers, we decided that we are not going to depend on them. We are going to develop it on our own. And work has started. And we have reached a certain condition in which we are now integrated them and started testing it. It's a great news. But again, it's the first prototype that we have just made.
So we are building our own environment.
Using our own knowledge, our own skills in our industry.
Wow.
Yes.
Yes, let's give them this thing. So that technology is very critical. They don't like to part with it. Okay. Okay. And so where have we reached in that? We've now...
So we will be putting some part of it in our first unmanned mission. We will test whether the oxygen supply, the air conditioning, the water supply and removal of the humidity, the waste disposal, and oxygen, cleanliness of the air. So there are so many fire protection. All of these are built into it. I think we are trying to see that with unmanned mission it works well.
Just a ABC question. Yeah. What about the spacesuit? We'll have our own spacesuit with the color and everything?
We have our own spacesuit. It is under development. We made at least 5 different prototypes from, again, using the industrial system support available in India. But for the first mission, we purchased some spacesuits and kept in the shelf for guarantee of our crew. And we will take a decision whether to use it or not at the appropriate time.
What about Indian food? Are you going to serve Indian food?
Of course, only Indian food. And there are enough of industries, scientific research labs in India who is working on aerospace food. And they have developed quite a lot of food. And we have brought in specialists from NASA.
What, will you get idli sambar or what will you get?
No, they won't be able to eat idli and sambar in their short duration mission. But when they are in long duration mission, they will be able to eat chicken and various other things. That's no issue for them.
And all the good masalas can be put.
All of them, yes. But for short missions, it will be in a different form. They will be in a pelletized tube and similar forms because they won't be in a position to move and prepare it. So the short duration missions like 1 day to 1 week missions, they will have one type of food. Whereas for long duration mission, they need to take it out of the short sleeve environment. The entire food will be of similar nature that as we eat.
And what about the astronauts that are going, or what do we call some Gaganyauts, as we call them here? How many have been selected, shortlisted, and are there women in that? And how many crew will actually go up finally?
See, the astronaut pool is something that we need to develop over a period of time. So what we did is we have only one astronaut in India, Rakesh Sharma. Of course, he has gone in a Russian vehicle, and we have huge amount of exposure, experience from him shared with us. And he's with us while we are selecting, training the people. The only place I can look for astronaut is Indian Air Force. And they are the pilots who have the ability to withstand those type of environment. And we have picked four such pilots who are into the fighter plane. They were testing pilots, and they have joined us as astronaut trainees. And they have gone through the entire training program in other countries. They have come back. We are setting up the training facilities, and they are going through coursework, simulation training, etc. Now they are student trainees of astronauts, and they will graduate themselves, and using their exposure to whatever training they have done, we are designing and developing the module in which they sit. So it's actually designing a car in which a driver is already experienced with, and his experience is used in designing the car. It's something like that, yeah.
And is there any female in that thing? Will we see India's
See,
first?
right now we don't have even fighter pilots.
Right.
Women are not there. So naturally, when I look for them, they are not available at this moment. I'm sure they will come at maybe a little later when we expand the pool.
Now, just a comparative thing. We have seen, various private companies going up to space. You had Bezos's company, Jeff Bezos. You had our Elon Musk. They're putting up people into space. This thing. What is why is ISRO taking so long? If these chaps can come 10 years, 15 years, and then put someone up in space, and here we've had a space program that is almost contiguous now, 50 years. Why hasn't it happened more quickly in India?
I think you need to understand the background on which that has really been developed in US. When the US was sending space shuttle mission, they faced two very, very critical failures, and they had to shelve space shuttle. And when they stopped space shuttle launches, where it was capable of sending human space mission, America had no launch vehicle capable of taking human beings to space. And they were sending the human beings in a Russian craft for many years later. So for next 7 to 8 years, they had no rocket taking human beings to space. And they took a challenge in US when they shut down space shuttle. They funded heavily the private companies like Boeing, the SpaceX, etc., and multiple companies, government-funded money to create this capability. It is not a private company just like that doing a human spaceflight mission. The entire NASA experience is behind them. And using the already developed systems, knowledge, and skills of the NASA, the private companies could develop with huge funding from the government. And SpaceX itself took 11 years to develop the capability. Let us not forget the part. Their rocket, the initial rockets were failing one after another. And he was bankrupt, Just forget about the human launch, even the first taking of the rocket and landing, he couldn't achieve over a period of time. But it takes persistent effort and money and investment. And of course, you need a good leadership, of course, to create this capability. There is only one example, SpaceX. Of course, Bezos is developing rocket. It has not still been an operational rocket or launching satellites. He has developed capability. But Elon Musk is definitely an inspiration for all of us to see how a private entrepreneur is able to create a booming business in space. And it's an eye-opener for all the people in the world.
What about what developments that are happening in China? We see that China has close to 60 space missions every year. They have now announced that they would put their own human in the moon pretty quickly by 2030. How is that they're able to do so much and our ambitions are much lower? What's the reason behind that?
See, here again, I need to understand the geopolitics of space. It doesn't go just like the technology alone. See, when the Russians were collapsing and the nation was disintegrating and the Ukrainian space domain, which was essentially the technology support for the Russians, was not having any possibility of getting into space because they became a landlocked country. The entire space technology in Ukraine was for sale. Okay, and it was the Chinese who took advantage of the situation, and they moved much of the people, knowledge, skill in Ukraine and also partially in Russia to China. And whatever they developed at that point in time was based on this core knowledge available in those parts of the countries. Of course, they may agree, they may not disagree, but that's what we know about it. But then I can't underplay what they did because they had a huge support from the government. There is a huge investment. At least 10 times the people of space sector working in India are working in space sector, and they wanted it as a target to demonstrate their national superiority. It is not for science alone, for technology alone. I don't see there is a huge amount of business happening in China on account of space missions and human space activity. But they want to showcase that they are a superpower. Of course, it is their policy and decision that they need to do. But as scientists and engineers, we are excited to see even China doing wonderful things like the human space missions, their plan to go to moon, etc., challenging the supremacy of the US and other allies. So it is their political decision to do such a thing. But I will not compare that they are doing so fantastic and so much, why we are not doing. That question doesn't arise. It comes out of the national need. What exactly you want to do with the money and resources that you have at this moment? And I am very sure that we are very clear about it.
Now, one of the things we did, and we've got about 6 minutes left, is that we changed our space policy. Isro till now, Indian Space Research Organization till now, was the monopoly over all space activity, whether building rockets, sending out satellites, having your stations that are there to launch them. The government, the Modi government has changed that dramatically and allowed private players to come in. How significant is that move? Can we now see more Bezoses, Elon Musks that India has? Do we have the capability, or are they doing only low-lying technology that's there?
See, the narratives of the Elon Musk and Bezos is not applicable to India. I think let us understand, again, I mentioned that the ecosystem in the US at that threshold of changeover from NASA more dominated to private was at a different time. They were already having private people, the Titan, the Delta, they were all in private company-owned rockets. In America, they were launching rockets by private companies, fully built, designed, because they are huge techno companies who are into the defense sector and they know how to build missiles. All the missiles of the Americans are not built by the government, they are built by the private companies, even today. And they started much before government started doing it. Now think of the Indian situation in which, when there was no space activity in India, government invested to create Isro. And Isro became responsible to create the capability in this country. And we brought in industries, supplier chain into our midst. And we have at least 500 such companies today doing space-related activity, high-end technical activity today. Just because ISRO did this, today we have an ecosystem around available in this country capable of doing aerospace-related work and related activities. It is not a small task. Last 60 years we did that. But now the challenge is they have to upgrade themselves to the people like Boeing. They must be having capability to have end-to-end design capability. They must be able to do business. They must be able to provide solutions for the space sector. Building satellites, building rockets if they want, building applications without ISRO support or even with ISRO's mentoring. How to bring that change? This is a question. Unless we do that change, the business side will not expand. We need investment in this. We need more jobs to be created. Our industry should be capable of doing it. And we have reached an inflection point at this time. Unless we do the opening of the space sector, it will continue in this mode with a very low scale of operation. So we see now the space sector is global. There is a business opportunity outside. We can build and export satellites. We can build and export applications. And we can bring in a reasonable amount of predicted revenue to this model. So that's why the space sector is opening.
And will ISRO, because I saw recently there was a Hyderabad startup, Skyroot, that sent up its first launcher. You have a whole range of people both in the satellite. Do you think that when it comes finally in the coming years, all your launches will start moving towards private sector? You would actually, all the needs that you all are meeting of India's private sector will now be dominated by private sector launchers and satellites?
See, I won't simply use the word private sector, launches will move to private sector. There is nothing like that approach. We are encouraging private investment in space. So it will include applications, which is the 85% of the space business is in application delivery of services, which includes communication services, remote sensing services, strategic services. I believe that biggest of the business will be in that sector. Now comes building capability in terms of satellites, ground station, receiving equipment, communication equipments, which is not even there in this country. You have to bring those industries to build receiving stations, communicate network, equipments, etc., which is again 30-40% of the overall business. Now, look at the satellite building. It is hardly 15% of the overall economic scale of economy. And rockets are hardly less than 10% of the overall size of the market of the space. So, the niche markets are very difficult to reach. Building rockets and launching in private is not easy because the 2-3 failures will kill a company. So what we do is we do a very calibrated approach. ISRO will support these private players who are coming into rockets, handhold them, try to develop that capability and look at what innovative things they are bringing in, not routine. So we are allowing them to take on whatever knowledge we have, give help from higher. Similar thing for satellites. But in the application domain, we don't have to do that. There is already an innovative ecosystem available, and we only have to allow them to do without government control.
Well, we're almost out of time, but let's ask you about our mission to the sun, Aditya. When is that going up? That sounds very exciting.
Yeah, that's going to go in August.
Oh, wow.
Yeah,
Okay.
so we have just prepared the satellites, getting
Lovely.
ready.
Right.
And maybe that's a window available for going to moon again for all
And what
launches.
will we do? What aspect? How close will we
See,
get to the sun?
We will see, moon, its orbit. The location where the satellite will be 4 times the distance of moon from
Wow.
Earth. So there is a point called L-1. It's a Lagrangian point L-1. It's a field where the gravity between sun and Earth will neutralize. And if you send something there, it will stay around that point. Okay, so we will take the satellite there. You leave it there. It will simply move around a fictitious point and will continuously look at sun.
For how many years?
As long as the satellite lives. So
That's about 8-9 years, or
no, our designs are for 5 years.
okay.
But
And what will it do? What will it stare
what
at?
it does is, see, it will look at the sun and look at the corona. And
Right.
corona has very lot of activities in which that it ejects coronal mass. Recently, you would have heard there is a solar storm hit the Australians and New Zealand area and disrupt the entire communication networks. We have weather, space weather, which is very important. So we put instruments to look at sun, predict such coronal mass ejections, do remote sensing of the sun, and also when the particles are coming, much before it reaches Earth, we will be able to give warning to us. This is only the part of the service part of it, but there is a huge amount of scientific interest in understanding the processes that are happening in sun.
And is this the farthest in space that this thing, or Mangalyaan was further than this?
Mangalyaan was further away, no? Of
Okay.
course, it is, we are just around the moon only.
And
Yeah.
finally, since we have hit zero, what is your favorite moment? You've been a rocket specialist. What is your moment that when you look back, you say, that was something I did. You've been 40 years in space, or 38 years in space.
I am 38 years plus.
Yeah.
Okay, see, I was a project director of a rocket. I was responsible to design and develop the LVM-3, which is going to be the human
That's the heavy lift vehicle.
Heavy lift vehicle, which
Just to explain that earlier we had capacities of 2-ton satellites.
Now we have
4-ton
4-ton
satellites.
plus.
Now we have 4 tons to 8 tons. We can go up to if you want to. Yeah.
So this rocket was being developed, and I joined the team. And when it was launched, the very first time, I was a mission director. See, the joy that we get when we actually sketched this rocket to write a project report, maybe 10 years back. I was making a drawing on an A4 sheet of paper or engineering drawing, an idea to put up a project report, doing its basic design at some point in time in my life. And later, 10 years later, you see the rocket standing, ready to get launched, massive 600-ton, manufactured, designed, and developed by Indians, mine by team. And what a joy that you see looking at it taking off, no? It's like a mother creating a baby and then seeing it growing and taking places, going places. No, you feel similar enjoyment in life. I think nothing can match that.
Dr. Somnath, you are a real hero of India. Congratulations, and to all your scientists and your team. Ladies and gentlemen, let's give them a very warm round of applause for this. Thank you so much.